Hello everyone. Today we shall learn displacement reaction and double displacement reaction under the heading types of chemical reactions. In the previous class we discussed about combination reaction and decomposition reaction under the heading types of chemical reaction. Now let us start with displacement reaction. Displacement reaction is a reaction in which more reactive element displaces less reactive element from its compound or from its aqueous salt solution or from acids or water. Generally, displacement reactions are exothermic. They are also called single displacement reaction. Now students, elements are arranged on the basis of relative reactivity and the series derived from it is called reactivity series. And on the other hand, elements can also be arranged on the basis of their tendency to lose electron and the series derived from it is called electrochemical series. Students, you will learn about the electrochemical series in your higher class. Now, arrangement of common metals in decreasing order of their reactivity is called reactivity series of metals. Now, from the reactivity series, you can able to analyze potassium, the most reactive, and platinum, the least reactive. Now, in the reactivity series of some common metals, you can easily see the presence of hydrogen. Hydrogen, like metals, easily lose electrons to form electropositive ion or H plus ion and thus help us to compare the reactivities of metal. Similarly, the reactivity series of halogen in decreasing order is from fluorine to iodine. Let us take up some examples of displacement reaction. Iron in unrested form, greyish black in color, when treated with copper sulfate solution, which is blue in color, turns blue color into pale green color of ferrous sulfate solution with the deposition of copper at the bottom of the beaker. Now student, the blue color fades to green color because of the formation of ferrous sulfate. From the reactivity series, you can able to see that iron is placed above copper. So iron is more reactive and therefore capable of displacing copper from its aqueous salt solution to form ferrous sulfate and the red deposits of copper. Let us take up one more example, zinc when treated with dilute HCl. You can see from the reactivity series, zinc being more reactive than hydrogen is capable of displacing hydrogen from acid and remove it in the form of hydrogen gas. The identification of this gas is done by bringing a burning splinter near the mouth of the test tube. It produces pop sound and it may catch fire. Why? Because hydrogen is highly inflammable. One more example where iron, red hot iron, is treated with steam to form magnetic oxide and hydrogen gas. You can see from the reactivity series, iron is more reactive than hydrogen. So, it is displacing hydrogen from water in the form of hydrogen gas. One more reaction is that when iron oxide treated with aluminium powder. You can see from the reactivity series, aluminium is placed above iron. So, aluminium is more reactive than iron and therefore displaces iron from its oxide to form aluminium oxide with the molten form of iron. This reaction has a special name called thermite reaction because large amount of heat is produced in this reaction, which is used for welding railway tracks. Now one more example where chlorine is treated with potassium iodide. You can see chlorine is more reactive than iodine, displaces iodine from potassium iodide and form potassium chloride with the liberation of iodine. Now let us take up double displacement reaction. Now let us see double displacement reaction, also called double decomposition reaction. It is a reaction in which two compounds in a solution reacts to form two new compounds by mutual exchange of radicals. Listen students, double decomposition reaction may also occur with the evolution of gas. Let us see the example. Iron sulfide, when treated with dilute HCl, here I have taken dilute HCl, iron sulfide when treated with dilute HCl forms ferrous chloride with the evolution of H2S gas, that is hydrogen sulfide gas. We can identify the presence of hydrogen sulfide gas by its smell, which smells like rotten egg. Now, double displacement reaction can also be classified under precipitation and neutralization. Let us take up precipitation reaction. When two ionic compounds in their aqueous state reacts, or when a gas is bubbled through solution, in both the cases there is a formation of insoluble solid, and this is called precipitate as one of the product, and it includes exchange of ions between the reactant. Let us see one example. Lead nitrate aqueous solution when treated with potassium iodide in aqueous medium forms lead iodide, which is a yellow precipitate, and potassium nitrate as aqueous solution. Now this is an example of precipitation reaction because the formation of yellow precipitate. One more example where gas is bubbled through solution. Here which gas is taken? Carbon dioxide. It is bubbling through which solution? Slaked lime. You can see there is a formation of insoluble milky suspension as a precipitate, and so this is also an example of precipitation reaction. Now one more type of double displacement is neutralization reaction. The name itself is telling that there is a formation of neutral substance. So when an acid reacts with a base to form salt and water only, then the reaction is called neutralization reactions. Such reactions are always exothermic, and all neutralization reaction where the salt formed is neutral to litmus are actually irreversible reaction. So students able to understand about the single displacement and double displacement reaction? Stay tuned for the next class.